a couple questions actually on areas and volumes. Alrighty, so let's look at this question number 5 here. This is no calculator question. So as you can see, we have two functions. F of x is equal to 2x squared minus 6x plus 4, and then the other one is a cosine function here. So if I were to highlight this one for you so that you could understand better, you see f of x, this is a parabola. I mean, when you look at it, it's kind of difficult to see which one would have been parabola, which one would have been cosine function. But you see, in case of a parabola, axis of symmetry is a positive, about 1.5 here. So negative 6 over 2a, which is 4. So you can see that this is turning right at that particular point. So you can see this yellow one right over here, the one that I'm highlighting, would have been f of x. All right. Then likewise, how about this one? Cosine function would have been this green one, would have been my cosine function, so that we can understand a bit better. Now what I want you to do here is first find the area. Now, in order to find the area, we're just going to area between those two curves. Then what we're going to be doing is top minus bottom. So for A, area is equal to top, which is the cosine function. So 4 cosine of 1/4 pi x minus this one, parentheses 2x squared minus 6x plus 4 dx. But you have to wonder, what should be my boundaries? It looks like 0 and then 2, but I need to make sure. So when x equals 0, what will be the value of y? So when x equals to 0, my y value is 4, okay. And when x equals to 0, cosine of 0 equals 1, so hence my y value becomes 4. That does make sense. This is the intersection 0, 4. How about this one? It looks like 2, but I just want to confirm. When I plug in 2 in place of x, will my y value be equal to 0? So when I plug in 2 here, this one is 8. When I plug in 2 here, this is minus 12. So 8 minus 12 becomes negative 4, plus 4 becomes 0. So yes, f of x does indeed pass through 2, 0. When I plug in 2 here, then 1/4 pi times 2, then it becomes pi over 2. So cosine of pi over 2 is equal to 0, so the whole thing becomes 0. So yes, indeed, this point is 2, 0. So yes, the intersection is going from 0 through 2. So I'm going to write that down, 0 through 2. Now, for the first one, you see, I can let this one as my u. Then what do you end up getting? If you set that as u, pi over 4, x, then what is my du? Du equals pi over 4 dx. So then when I integrate this portion, yes, in fact, it becomes, I have to multiply by 4 over pi, so it's going to become 16 over pi, and then cosine becomes what? Sine of pi x over 4. That's what we end up getting. Now, second one, I will end up getting minus 2/3 x cubed. And then, how about the second one? It becomes minus 3x squared plus 4x, where it is bounded by 0 and then 2. So let's look at this one at a time. If you have to plug in 2, what do you end up getting? When you plug in 2, what you end up getting is, first one becomes sine of pi over 2. Well, sine of pi over 2 equals 1. So very first term, it remains to be 16 over pi. That's the very first one. Let's look at the polynomial here. Minus. When you plug in 2 here, it becomes 16 over 3. Now, second one is when you plug in 2, it becomes minus 12 and plus 8. But when you plug in 0, everything disappears to be 0. So this is my answer. So if you want to simplify this one further, first one is simply 16 over pi, doesn't change at all. And this one is minus 4 between negative 12 and then 8. So 16 over 3 minus 4, which is 12 over 3. So what we end up getting is minus 4 over 3. That becomes our final answer for part A. Let's look at part B. It says write but do not evaluate the integral expression that gives the volume of the solid generated when R, the region R, is rotated about horizontal line y equals 4. What the y equals 4, if I have to sketch that, it would have been something like this. And then this one is revolving around that particular axis. Then you can see here that we have a space between the axis of rotation and then the area R that's being rotated about, rotating. So then we have to use the washer method. So then, of course, we're going to do pi big R minus pi small r. But what is a big R? Big R is from here to all the way here. So then, a volume, once again, goes from 0 through 2. Let me try to put pi in the front. 0 through 2. What is our outer radius? It's from here, which is 4, all the way down to yellow line. Yellow line was the f of x. So what we end up getting is 4 minus f of x squared. That's pi big R square minus, what is the small r? Small r is from here to here, you see. From y equals 4 all the way down to the green line, which is g of x. So 4 minus g of x. That's the small r and the square and dx. So that will be the integral which you can set up. Alrighty. So with that one, I'm going to stop for part B. Let's look at part C. In case of part C, we have the region R is in the base of the solid. For the solid, each cross section is perpendicular to the x-axis is square. So that means, let me try to use blue. So that means I have a square that goes up this way, square that goes up that way, and so forth and so on. Then part C, what's going to be happening is, right, but do not evaluate. So we just have to express the expression. Volume is equal to squares. How do you find the square? Length is the difference between the f of x and g of x. But to find the area, we have to square that. So what we end up getting is upper one, which is g of x. Because, I mean, it doesn't really matter because we're going to square them, but it would have been g of x minus f of x squared dx, where it goes from 0 to 2. So that would be the expression which we can use. All right, so that was number 5 here. Let's look at the next question. Number 2 from 2014. All right, so here we have to, for this question, we have to use calculator. Let R be the region enclosed by the graph here, f of x equals this one. So I'm assuming, since this is a quartic function, I'm assuming that this function f of x would have been this one. It goes down all the way and horizontal line y equals 4, then this must be y equals 4. All right, find the volume of the solid generated when R, this region, is rotated about the line y equals -2. So y equals -2, where is that line? It would have been down below. And in this case, we actually have to find the volume, not only setting it up. So what I'm going to do is we have to get to what? Outer radius and then inner radius. Outer radius would have been this one. From 4 all the way down to y equals -2. So total 6 units. Inner radius would have been this one, which is f of x minus -2. So to answer A, and then where are we going from and where are we going to? So we need to find an intersection as well. Now, then let's try to get this one together. So I'm going to take out my calculator here. I'm going to put down my equation will be x to the 4th minus 2.3 x to the 3rd plus 4. All right, and then second one is equal to 4 here. And I'm going to sketch them and then try to find the intersections. So we have 2 intersections over here, it seems. What are those intersections? I'm going to do second calc. And intersection number 5. That's the first curve. That's the second curve. That's your intersection is 0, 4. So one of the intersection is 0, 4 right over here. Let's find out the second intersection. What is the second intersection here? Number 5. First curve, second curve. Right before the guessing, you just have to go near the intersection. Then 2.3. Okay, so here we get 2.3, 4. Alrighty. Then the volume equals pi. That goes from 0 through 2.3. And then outer layer was 6 because 4 minus -2, so we get 6 squared minus inner radius is what? F of x minus negative, so we get plus 2 squared dx. So that's basically what we end up getting. Now, then I'm going to put this one into calculator and then see what happens. Second, quit. So what I want to do is I want to multiply that by pi, so I'm going to do second pi times the integral, math, integral, going from 0 through 2.3. And then first one is 6 squared minus parentheses. F of x, we store that as y sub 1. So alpha, y sub 1, that one. And then plus 2, quantity squared. Okay. And then it was against x. So when I do that, then I can see that this is my value. So my answer will be 96 or 98, I believe. 868 would have been my answer. All right, that wasn't that bad. Let's look at part B. It says region R is base of solid. For the solid, its cross-section is perpendicular to the x-axis. It is an isosceles right triangle. Isosceles right triangle, all right? I'm thinking about different formulas that I can use, where a leg is in R. So that means you can see that, hey, I have an isosceles right triangle. It goes up this way and then coming back down, where this is a right angle. and this leg is equal to each other. So base and height is in fact equal to each other. If I have to draw another picture. So base and then height is equal to each other because it's isosceles right triangle. Then area would have been 1/2 the side square, because side is base and side is the height. But this length is the difference between y equals 4 and then f of x. So what I'm going to do is to find the volume. Now I gotta have 1/2, which goes from 0 to 2.3. Top is what? 4 minus bottom is f of x. So that is the side, length of a side, top minus bottom. And then we gotta square that because we're squaring it over here at dx. Then let's see what we end up getting. So second one is 0.5 times second math, just math number 9 goes from 0 to 2.3, and then we're going to square 4 minus f of x, which is y sub 1. So I'm going to go alpha trace, okay, that one, close parentheses, square, and dx. Then you can see that my answer should be 3.574. That becomes my answer. All right. Let's look at part C here. Part C, I'm going to use a different color, is vertical line y equals k. So I don't know where it is, but imagine y equals k somewhere here. Divide R, this region, into two regions with equal area. So that means 0 through k has to be equal to k through 2.3. Once again, right, but do not solve the equation involving this expression. All right, so that means, simply put, area of the first half has to be equal to second half. So that means from 0 through k. Wherever the k might have been, 0 through k of that area. So that means top minus bottom. So I'm going to do 4 minus f of x dx should be equal to, from k to 2.3 all the way till the end of the same expression, 4 minus f of x dx. So that's it. That's what we can do. Good job, and I'll see you later.